Alrighty, so now that we were able to check and plugged in -12, -8, 0, and 3 into R2x plus 20 over x minus 2, x plus 6. Make sure that you are checking, and we notice that this side, this interval was less than 0. Now in the middle, it was actually positive, so this one did not work. And then we also had something, a value that's negative between -6 and 2. So this will also shade. And this one does not work either. So my solution, once you check your work, is -infinity up to -10, inclusive the -10 union, parentheses, -6 to 2, parentheses. Remember that the ones that have parentheses means that the boundary points are not included. Whereas if I have a bracket, that means that it will be included. Alrighty, let's talk about number 9. We wish to solve applications involving polynomial and rational inequalities. Let's say that Fumio is constructing a circular koi pond in his backyard. What range? So we're trying to find what range of values may he have for the diameter. So we are going to be restricting the diameter in this case. We are going to restrict the diameter here. What range of values may the diameter have if the area is no more than 78? So no more than 78.5 square units. So no more than means what? 78.5. Alrighty, so then what we're trying to do is, well, we know the area formula for a circle is pi r squared. But right now we are focused on the diameter, so r is d over 2 because the radius is half of the diameter, and we want everything in terms of a diameter. So if we substitute it, if we want the diameter, we have pi d over 2 squared should be less than or equal to 78.5. Now, the next thing is, well, if we clean this up, we're going to get pi d squared over 4 because d over 2 squared is d squared over 4 less than or equal to 78.5. And then we're going to get an inequality. Now, pi is approximately 3.14. So if we divide 3.14 divided by 4, then we have d squared less than or equal to 78.5. And then what is 3.14 less over 4? We punch this in our calculator, we get 0.785 d squared less than or equal to 78.5. Now we are going to be solving this inequality. So to solve, we're going to bring everything to one single side. 0.785 d squared minus 78.5 is less than or equal to 0. Now the next thing is we wish to factor 0.785 from both sides. That's going to give me d squared minus 100. So if I factor, see how it's 78.5 and 0.785. So if I multiply 0.785 times 100, I should get back 78.5, which is less than or equal to 0. Now, because I factored, I'm going to set my factored form d squared minus 100 equal to 0 to find my boundary points. And then notice that those boundary points will be included because I have a less than or equal to. So this gives me d squared, or d minus 10, d plus 10 using difference of squares. So d is equal to 10 and negative 10. Now, because I'm looking at the diameter, I'm looking at a units, negative 10 will not be part of my answer. Only positive values. So then what do I have to look at? So if these are my boundary points, which are negative 10 and then 10, remember these are typically included, but we are going to remove negative 10, but we can include 0. So 0 and something greater than 10, let's say 20. I have to test a point right in between negative 10. So my initial positive answer will be from 0 to 10. And what are my values there? I'm going to have to determine which intervals will work. So I'm going to plug in 0 and I'm going to plug in 20. So if I substitute 0 minus 100 times 0.785, I'm going to get 0.785 times negative 100. That's going to be negative 78.5, which will work. So this part will work. Now what happens after 10? Let's say 20. If I put 20, it's going to be 0.785 times 20 squared minus 100. Is that less than or equal to 0? No. So my only answer is going to be from 0 to 10, including 10, where my largest value would be 10. My largest diameter would be 10. Because at 10, I will get 0. I will get the equality. So just be careful. So your regular is going to be negative 10 to 10. But because we're looking for a diameter, it's only positive answers. So it has to be, I'm going to test a 0, anything between 0 and 10, and then anything after 10. And the only one that worked was from 0 to 10. Okay. Let's look at the last question. The C cost in dollars produce X items given by the function cost C of X, 0.5X plus 150 over X. If the cost is kept below, so it's already saying below 20, how many items may be produced? So they're saying that the C of X should be below 20. So we create the inequality. And in this case, this inequality will be a rational inequality because I have a fraction in there. So I have 0.5x plus 150 over x less than 20. So then the first thing that I want to do is I want to be able to clear fractions. So to clear fractions, I'm going to multiply both sides by, I'm going to rewrite the 0.5 as x over 2 because 0.5 is a half plus 150 over x less than 20. I'm going to multiply everything by my LCD. That LCD is going to be 2x on both sides. So then if I multiply by 2x, I'm going to have 4x squared over 2 plus 300x over x less than 40x. Now here I'm going to have 2x squared plus 300x less than 40x. Oh, sorry, let me go back here. Plus 300 because the x's will cancel here is less than 40x. And then I'm going to bring my 40x over and simplify. I'm going to get 2x squared minus 40x plus 300 is less than 0. And let me see here. I had, this is 2x times x. Let me rewrite this. See, there's a typo here. This should be 2x squared. So then this is just plain x squared. Sorry about that. So the first thing is multiply everything by 2x. So 2x times x is 2x squared. Let's go ahead and fix that. And then 2x plus 150, it's 300x. Now that I have a quadratic inequality, this gives me a quadratic inequality. I'm going to have to factor. So if I factor two values that multiply and give me 300 but add to negative 40, that's negative 30 and negative 10. So this factors as x minus 30, x minus 10, which is equal to 0. And then I'm going to be finding my boundary points. So that's going to give me x minus 30 is equal to 0, x minus 10 is equal to 0. I will get x is equal to 10 and x is equal to 30. Now they are not included because of the fact that I have a strict inequality. The inequality is strict. So I have 10 and I have 30. So I'm going to need some test points. I'm going to test 10, I'm going to test 15, and I'm going to test 40. And I want to know the values of that. So I'm going to test them right here. So I'm going to test, I'm going to do my test points as x minus 30, x minus 10, less than 0. So when I plug in 0, when I plug in 0 as my test point, 0 minus 30, 0 minus 10, negative 30 times negative 10. Is that less than 0? No, so I will not shade this region. Now, if I plug in anywhere between 10 and 30, let's say 15, it's 15 minus 30 times 15 minus 10. I get negative 15 times positive 5. Is that less than 0? Yes. So I will shade this region. Now anything over 30, so let's say 31 or 40, if I plug in 40, 40 minus 30, 40 minus 10 gives me something positive, so I will not shade this region. So the only solution is the shaded region between 10 and 30, excluding 10 and excluding 30. So that means that if I'm excluding 10 and 30, I will need between 11 and 29 items, inclusive. So these are the items that may be produced. That may be produced because this is an application problem. And with that, we terminate section 2.6. Thank you, and I'll see you guys next time.